Now I will be explaining to you another example on nodal analysis. Here we have to find the solution for the problem. Find the currents I1, I2 and I3 for the network shown in the figure. Okay, there are three currents I1, I2 and I3. As we are performing nodal analysis, initially we have to identify the nodes. Node V1 and node V2. It's given in the question. If it is not given, we have to assign the nodes. So, first we will write the KCL for node V1. KCL for node V1. So, KCL for node V1. So, we have to identify the currents in node V1. 1, 2 and 3. 3 currents. Let this direction be any. So, we have assigned 3 directions. So, according to this directions, we can write the equation. First, we can write this current. That is V1 minus 0. So, there is no need of minus. V1 by 2 plus V1 minus 25 by 5. V1 minus 25 by 5 is the current in this branch. And next plus V1 minus V2 by 10. V1 minus V2 by 10 is equal to 0. So, we have taken all the 3 currents as positive because we have taken the currents as moving out of the junction. So, now we can rearrange this equation as 0.8 V1 minus 0.1 V2 is equal to 5. This is equation number 1. So, now we can consider the next node, that is KCL at node V2. So, at node V2 we can consider 3 currents 1, 2 and 3. So, first we will be going for this current, that is V2 minus V1 by 10 plus V2 minus 50. See, this potential of this voltage source is given as minus plus. So, we have to write minus 50 by 2 plus V2 by 4 is equal to 0. And now we can rearrange this equation as minus 0.1 V1 plus 0.85 V2 is equal to minus 25. And this is equation number 2. So, you can put in a calculator to find V1 and V2. There are 2 equations. Equation number 1 and equation number 2. And we can find the 2 unknowns V1 and V2 using a calculator. So, by using a calculator we can get it as 2.61 volt and V2 is minus 29.1 volt. So, here we have to find the currents I1, I2 and I3. I1, I2 and I3 are the currents we have to find. So what is I1? I1 is V1 by 2 minus of V1 by 2, isn't it? See here, I have mentioned V1 by 2 is the current flowing in this direction. So actually the question is find I1 and I2 and I3. So I1 in the question it's mentioned like this. So it should be in the opposite direction to this current. So that is why I'm going to put a minus sign here. That is minus of V1 by 2, that is equal to minus of 2.61 divided by 2, that is equal to minus 1.31. So that is I1. So now let us find I2. I2 is equal to the current in the second loop. That is, I1 is flowing in this direction. So we can consider I1 is supposed to be flow in this direction. So it has to flow like this. Therefore it should flow in this direction. So we can take V1 minus V2 by 10. So we can write I1 is equal to V1 minus V2 by 10. We know V1 and V2, that is 2.61 minus V2 is minus 29, minus 29.1 divided by 10, that is equal to 3.17 ampere. Okay, that is I2. And now going for I3. I3 is equal to, I3 is the current moving in this direction. It is same as V2 minus 50 by 2. Sorry, not minus, minus of minus 50. That is V2 plus 50 by 2. V2 is minus 29.1 plus 50 by 2, which is equal to 10.45 ampere. Okay. So now we have solved for I1, I2 and I3. That is all. Thank you.